Greetings, fellow scientists. We have so much stuff to talk about today, and I mean actual stuff. All the things around you are made out of something that we call matter. This table is made out of matter. I'm made out of matter. You're made out of matter. Everything is made out of matter. But what is matter? Well, matter is anything that takes up space and has mass. It's made out of little tiny building blocks that we call atoms. And in fact, when you take those atoms and you put them together, they make small groups that we call molecules. So how do these building blocks come together to make so many different things? Well, it turns out that matter can act very differently and have different states depending on the space between those atoms and how much energy those atoms have. The type of matter that makes up things that are solid are called, well, solids. Solids includes most of the things that you're actually used to seeing in your everyday life, whether it's the clothes that you're wearing, the ground that you're standing on, the device you're watching this on. All those things are solids. What makes a solid is that other types of matter cannot pass through them. Watch this. If I take one hand, the other hand didn't go through, means that they're solid. Not all solids are the same. They have a range of different properties, from being, well, hard, soft, light, heavy, a lot of different kind of properties in between as well. For example, let's take a look at this piece of surgical tubing. It's pretty soft and pretty squishy, and it also has a whole bunch of stretchiness. Compared to this table in front of me, these things seem like they couldn't be any more different, right? Well, it turns out that solids have different behaviors depending on what their temperature is. At room temperature, surgical tubing is soft and stretchy. But what do you think will happen when we take this and we put it into our handy-dandy liquid nitrogen? Liquid nitrogen, remember, is minus 196 degrees Celsius. Let's find out. Well, as you can see, the parts that didn't go inside of liquid nitrogen are still soft and stretchy. But the part that did go into liquid nitrogen has become hard and rigid. And because of that, its normal property has really changed. The reason that this happened is because when things get cold, they lose all of their energy. That gives them the normal properties. The molecules of the solid get closer and closer together, and they become harder and more brittle. That's why you might have noticed that things that are frozen are usually easier to break. That's some pretty solid science right there.
Hey, how you doing? Tommy Tungsten here for Elements R Us with another super special sale. Mercury. It's a shiny silvery metal that's a liquid at room temperature. How cool is that? Just because it's a liquid though, don't mean you should be drinking none of it. This stuff is super poisonous to all living things. That don't mean it can't be useful though. As a liquid, it's so dense that even super heavy stuff like bricks can float on its surface. And let me tell you, you're not gonna find a better way to float your bricks. Turn it into a vapor, put it inside a fancy glass tube, and bada bing, bada boom, you got yourself a super efficient low energy light bulb. And if you know your science real good, you can even use mercury to extract gold out of rocks. Talk about bang for your buck, am I right? So swing on by Elements R Us real soon, because this silvery stuff is going quick. When you get there, tell them Tommy sent you, capiche?
Let's talk about gases. Gases are types of matter that have their atoms very far apart. Because their atoms are so far apart, they're able to have a lot of things go through them. Here's an example. Take your hands, put them in front of you like this, and try waving them back and forth. Right now, your hands are going straight through the atoms of the gas that is air. In fact, as we just said, air is a gas. So if we all take a deep breath in, we all just breathed in a gas. Well, actually, we breathed in a whole mixture of gases. You've probably heard about some gases, like oxygen and carbon dioxide. But air is actually made out of a whole bunch of different gases. One of the main ones that make it up is something that we call nitrogen. Nitrogen is something that's actually really interesting. We can use nitrogen to explore a whole bunch of states of matter. At normal temperatures, nitrogen is a gas, just like in the air around us. But with a little help from science, we can actually turn that nitrogen into a liquid. And while it's a liquid, liquid nitrogen is a frigid minus 196 degrees Celsius. It just so happens I have a bucket filled of liquid nitrogen right now. This liquid nitrogen is going to help us see what happens when gases get really cold. These balloons back here are filled with regular old air. They take up a lot of space because all of the atoms of air are really far apart. In fact, do you think we can fit this balloon inside of this bucket? Do you think we can fit all of those balloons inside of this bucket? Well, let's find out. Wow. So I managed to actually fit all of those balloons into this container of super cold liquid nitrogen. As we do that, all the air inside of those balloons is starting to lose energy. And because it's losing that energy, they're starting to shrink and get closer and closer together. Because of this, the balloons have shriveled up. In fact, let's take a look at what that looks like in just a minute here.
A few minutes later.
So what do you think these balloons look like now? Let's have a look. Let's see what they look like. So the balloons got much, much smaller. They shriveled up. Because of that, they become very, very small. As they start to heat back up, the balloons start to have all the air inside of them expand again, and they go back to being their normal state. Wow, how cool is that? Fellow scientists, thank you so much for joining us and learning about states of matter and gases today. If you're interested in learning about any of the other states of matter and seeing more liquid nitrogen in action, check out our other videos. Stay curious.
Hello everyone, I'm Sally Science, and I love it when you send in your questions for us to explore the answers together. And today we have an awesome question. Have a look.
My science question is, are there such thing as magnetic rocks?
Thanks so much for sending in this question. I'm so fascinated by it. And the answer is absolutely yes. Magnetic rocks do exist. How cool is that? So, do you know that all rocks are made of minerals, but not all minerals are magnetic? What makes magnetic rocks super duper cool is that they're made of a mineral that's an iron ore called magnetite. This is magnetite. Magnetite is a naturally occurring magnetic rock, and it's found all over the Earth. Do you guys know what a meteorite is? Well, a meteorite is a rock that falls from space, and most of the meteorites that we've found here on Earth also have magnetite in them. That means there are magnetic rocks on Earth and in outer space. How cool is that? And another cool thing about magnetite is that long, long ago, people used to tie pieces of magnetite to a string and use it as a compass because it would always sway to the north magnetic pole. To show you that this is a magnetic rock, I'm going to take this piece of magnetite and I'm going to put it on top of this magnet and see what happens. Ta-da! Magnetism. So now that we know magnetic rocks exist, let's talk a little bit about what makes them magnetic. Magnetism is a force that's all around us. And if something is magnetic, that means it has properties that want to pull objects together and push objects apart. Let's see it in action. Here, I have two magnets that look pretty much exactly the same, except you'll notice that one end is red and one end is black. And that's because they're opposite poles. So let's see what happens when I try and push those opposite poles together. Look at that! They are attracting each other. So let's try something else. What happens if I try and push both of the same poles together? Ooh! 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 They don't want to go together. Let me show you another way. I've got some smaller magnets that might make it easier for you to see. Here are two magnets also the same pole. And look what happens when I try and push them together. Oh, they keep running away from each other. They're not very friendly, are they? Well, kids, it's been so much fun talking about magnets today. I could probably talk about magnets all day long, but I've run out of time. Thanks so much for sending in this great question. If you've got a question, please send it to me, and I'd love to work together to find out the answers. Have a great day, everybody. This is Sally Science.